Hi, and welcome back to Grandpa's School of Hot Rod Building, Part 2. For those of you who are watching this series for the first time, we're building a 41 Willys Coupe modified to fit a Chevy S10 pickup chassis. Supplier of this Willys body is Scott Rod Customs in Monroeville, Ohio. The engine I'm using for this project is a small block Chevy V8. The distance between the motor mounts and the back end of the engine where the transmission mounts is 16 and 3/32 of an inch. This gives you about 2.5 inches of clearance between the engine and the firewall, back of the engine and the firewall, if you build your motor mounts at 9 inches back from where they were originally on the S10. If you use some other engine and it has different dimensions, you have to adjust accordingly. This is a simplified Chevy S10 chassis drawing. Shows where the original motor mounts were located, and the 9 inches back is where you're going to be welding on your new motor mounts. Do not purchase a universal motor mount. It's not going to fit because your lower control arm mounts are in the way. You're going to have to do some welding. A lot of welding on this project, so you may as well get yourself a welder, go on YouTube or take a vocational course in your community and learn how to weld. It's actually pretty fun. I want to take a moment and talk about the motor mounts that bolt to your engine. All aftermarket auto parts fall under one of three categories. There's the performance and off-road category, which is really great stuff. A step down is your OEM, original equipment components. They're designed to a budget, to a cost value. Then there's the stuff in China. It was redesigned by a Ferengi to maximize profits, and to heck with quality. Now, the reason I bring this up is because whatever motor mounts you put on your vehicle is going to determine what this dimension A is, the distance between your motor mount mounting points where they mount to the part you'll be putting on the welding to the chassis. So build yourself a fixture once you get your motor mounts on your engine and determine what this dimension A is. Now, dimension B is the distance from outside of rail to outside of rail on your S10 chassis at the point where you'll be welding your motor mounts. And those motor mounts you see up there in blue, that's kind of the idea of what you're going to be building. You're going to have to do a little bit of math to figure out how big to build your top plate. W is the distance between the two flanges on your engine's motor mount. Now, I went and got some 3-inch wide, 1/4 inch thick stock steel, and I welded a 1/2 inch diameter tube to it. Now, you can use a 1/2 inch Schedule 40 steel pipe used in the gas industry. You can buy at your local hardware store. Or I went on to McMaster Car and bought something with a little thicker wall. Anyway, you weld it to that plate, and the dimensions B and A we discussed in the previous slide. That gives you the distance from the center line of your motor mount to the edge of your chassis. The D, lowercase d, is the diameter of your round tube that you're welding on. And this lowercase I, that dimensional, you'll see it's very obvious in the next slide. If you follow this formula, you can build that top plate. Okay, this slide shows the top view and the cross-section view of your chassis where you're going to mount your top plate of your motor mount, shown in blue. We talked about lowercase I dimension in the previous slide. You'll see that thin line there in your top view. This is an overlap seam on the chassis. And there to the left is the brake bracket mounting holes. You do not want to cover those up. And also, the location there shown the arrows for the position where you'll mount this plate will vary depending on your engine and how much clearance you want between your engine and the firewall. So you get to calculate that or mark it, and for the 350, it's the center of that blue bracket we're welding on is 9 inches from the original motor mounts. Before you start welding, get out your jig that you used to determine dimension A and line it up with the parts you've now got clamped onto your chassis. If those line up, then when it comes time to put the engine on, it's going to fit like a glove. After you've finished welding on your top plate, you flip your chassis over. If you catch that real quick, you'll be able to see that in this drawing. Anyway, you're going to then weld a plate up against your lower control arm housing, as shown in step 1. Then a piece across from it in step 2 is shown, and then you close it in on the end of those 2 pieces in step 3. Then you grind away at all your welds, make them look nice and pretty, and use a rust inhibitor, primer and paint. Of course, there's a lot of grinding. But anyway, you'll end up with a real strong motor mount using this method. You can come with your own idea if you want. Scott's is a little bit different. Anyway, when you're done, if you want to bang on it with a hammer and just test how solid it is, go right ahead. It's your project. Do it your way. Now, when you get done with all of your welding, not just the motor mounts, but all of the weldments, you take your chassis outside and you grind and grind and grind to get as much rust off as you can. I use wire wheels on my drill motor. I have a Dremel tool. Sometimes I actually do get out a piece of sandpaper, and a wire brush, the welding brush, anywhere I can to get into those little nooks and crannies. Then you hit it with a good rust encapsulator, and then followed up by a primer and a good quality chassis paint. Just as safety, you gotta have a lot of ventilation while you're welding, but you don't want to, leave your garage door open and have kids and other people stare at you while you're welding. That's not good for their eyes. Also, all your painting, you don't want to do that indoors. You gotta have a lot of ventilation for that as well. Just use your head, common sense, and you'll be okay. Well, that's about it for today. In future videos, actually the next one I'm going to do is going to be, I'm going to talk about the rear end differential and setting it relative to the, it was talked about in the first episode, you're going to be moving your rear differential forward 6 inches, and I'm going to show you an easy way to do that. So, thank you for watching. Subscribe. You don't want to miss any of these things. Go ahead and make comments down in the comment section. I'll also leave a link there for Master Car, excuse me. Though a lot of you probably are already aware of them, they make a lot of machine parts, and that's what I used for my rod on my motor mount, the cylindrical part. So everybody take care. It's getting close to Christmas, so in case I don't get to the next episode before Christmas, Merry Christmas and Happy New Year, my friends.